And then without any delay, I will give it to our Unicorn colleague who will take us further in this session. Yeah, to Unicorn team, please.
Yeah, thank you, Vishnu, for the intro. So hello everyone and welcome once more. As Vishnu already mentioned, today's topic will be ECCo on Windows. My name is Daniel Janota. I'm currently working as ECCo analyst, and together with me there is Michael and TG.
Hello, my name is Michael Pinkas, and I have been working as an ECCo developer for over a year.
Hello, my name is ECCo, and I have been working with the ECCo project for 6 years.
Yeah. In case of any questions, please do not hesitate to raise your hand, and we will then ask you to ask the question, or you can alternatively send it to the chat, and we will get back to you. Regarding today's agenda, we will firstly check some new features within the spring and fall releases. We will check some deployment comparison with the previous version, and by the previous version, I mean the ECP 4.12 and EDX 1.13. Then we will go through the theoretical part, so some general information, prerequisites. There will be description of minimum hardware requirements, some network flows, communication protocols, etc. And then in the second part, there will be a practical demonstration of installation, configuration, and registration of ECP endpoint and EDX toolbox together with their internal broker, and also upgrade from the ECP 4.12 to the latest ECP 4.15, and also the EDX. So let's start with new features for the last two new releases, spring and fall release. There is a major design change or deployment change, which you can see on these two pictures. On the left one, you can see that the internal broker, which used the ActiveMQ Classic, was fully embedded to the ECP endpoint and EDX toolbox application. Both of them were connected to the shared external database, if configured. And on the right side picture, you can see the newer design of the deployment using the ActiveMQ Artemis, which uses a shared external internal broker, which is then connected to some file journal. In case of high availability deployment, it will be shared file journal, and the ECP and EDX, ECP endpoint and EDX toolbox applications are then connecting to the external database, or in case of the default Derby database, to its own local database. Regarding some properties that were removed due to this change to external internal broker, all the JDBC external broker and ActiveMQ credentials properties, which were connected to previous embedded internal broker configuration, were removed, so they are not already used, as well as the ActiveMQ database tables. In case that the ECP endpoint or index toolbox used some external database, all the tables for the internal broker were created within the database. However, as the internal broker is now a separate component and it uses file journal, the database is not used anymore. Also, the ActiveMQ auto-create tables property was removed and it's not used anymore. Regarding maybe some changes during the upgrade, it will be probably mentioned also in the practical part. The already existent ActiveMQ tables are not removed. You will need to remove them manually. However, that is or will be covered within the documentation. let's talk maybe about some more specific features, new features for Spring Release. Versions ECP 4.14 and EDX 1.14. The first obvious change is that we have changed the version number for the ECP endpoint. We have skipped the ECP 4.13. So right now the minor version numbers are aligned within the ECP and EDX. So there might be there should be no confusion of like what version EDX is for what version of ECP, etc., etc. Regarding some operating system support changes, central components, namely ECP broker, component directory, and EDX service catalog, are not supported on Windows anymore. They are supported only for Linux, or alternatively some container deployment using the Docker images. There are no changes in database support, so all the versions and all the databases are still the same. Regarding the compatibility changes, the support of ECCo external authentication was removed. So if you wish to use some external authentication, you need to use LDAP. And also, as the internal broker is now a separate component and not embedded to the ECP endpoint, and it uses a bit different technology, the naming of some Prometheus metrics was changed. Also, those properties for the internal broker are now available only on the internal broker, not on the ECP endpoint or the EDX toolbox, as it was on the previous versions.
Noi facciamo sulla leadership inclusiva, vedi, coinvolgiamo tutti 2 ore, 3 ore.
Yeah, as I already mentioned, the internal broker for ECP endpoint, EDX toolbox, and service catalog was removed, and instead of that, a new ECCo internal broker component is used.
ସେ ଯୋଉ
externally.
ଇଏ ଜିନିଷଟା ବଢିଆ ବାସ୍ନାଟା ହେଲା।
Also, the internal broker and ECP broker now comes with Prometheus metrics, came over it as well, but the ECP broker metrics were actually extended with certificate validity. So now you can check the validity of brokers certificates within the monitoring via Prometheus. Also, the fact that the internal broker is now fully external unlocks the option to use one shared internal broker for several ECP or EDX components, like several registrations within them. So you can also use some central ECCo Artemis for that. And last change mentioned here is EDX service catalog validates its network configuration file name. It will actually put its component code to the file name, and during the upload, it will check if the component code is present and if it is the same as configured within the EDX configuration. This change was made to prevent some accidental upload to wrong environment, etc. Regarding some features specifically for release, all versions ECP 4.15 and EDX 1.15, there is a operating system support change. The support for Windows Server 2016 was removed, and instead of that, we have added support for Windows Server 2022. In the same way as on the previous version, or the 4.14 version, there are no changes within the database support. Regarding the compatibility changes, the support for all network configuration syntax, the one without domains, was removed. So the EDX source catalog and toolbox will accept only the new syntax, including domains, etc. We have also added a database backup and restore feature. So now you can easily from GUI download a zip file which will serve as a backup, and you will be able to restore it. Also, the ECP endpoint now uses compound indexes for message table, which makes the message listing much faster. There was also another change that made the ECP endpoint not connect to unreachable broker. So if the broker is like down for some longer period of time or it was revoked, it will not try to connect back to it. And also the feature for the queue prefixes was extended for the ECP endpoint AX toolbox, and now it can use different prefix for business application use. So basically, let's call it like external queues, which are used for the integration to the ECCo. Maybe before we jump into the prerequisites and general information, do you have any questions regarding the new features? Probably not. So let's continue. All the information that we will mention today are covered within ECP and EDX installation and upgrade guides. So if you are more interested in certain topics, you can always refer to those guides. During the practical demonstration, we'll also go through some parts of the documentation, so we will know where to find each information. Regarding hardware requirements or minimal hardware requirements, you can see the table on the slide and presentation. Please note that these requirements are only estimations and they may change according to some performance requirements, the message traffic, etc. It's always better to firstly test your business on some testing environment, and from that get down the real requirements for the hardware. We also recommend using of virtual machines, as they can be easily resized when it is necessary. The most important information, though, is that the hardware requirements were not changed since the ActiveMQ Classic versions. So the ECP endpoint, together with internal broker deployed on the same server, still needs 4 cores for CPU, 8 GB of RAM, and 40 GB of storage. And Toolbox still needs 2 cores for CPU, 4 GB of RAM, and 20 GB for storage. Although the storage may differ depending on the message traffic, as I already mentioned. Regarding firewall flows, which need to be opened, obviously it needs to be done before the installation, so everything will work after the starting of the application. And there are basically 2 main categories of flow that needs to be opened. The first one is for ECCo components. They are described in a table below, as you can see. The second category is flows for external databases. They then depend on a used database and port that are being used by the application. So in the table you can see that for example for ECP endpoint there is port 8443 for like both ways, so remote and outbound connections. For Toolbox it's 8443 by default. However, when deployed on the same server, it's commonly changed to 9443. and that is for inbound connections. Regarding some communication protocols, for messaging, the ECCo uses an UPS, and for REST API, graphical user interface, as well as web service, the HTTPS is being used. Let's jump to deployment types. We still have two types of deployment: the standalone and high availability. The standalone mode is the simpler one. It requires no other services such database or some other shared storage, etc. By default it uses Apache Derby as its database. That database is then fully managed by the ECCo application, so you can just install it, start it, and start sending messages, for example. Also, it's important to know that it is possible to configure external database also within the standalone mode. The second option for the deployment, or the second type, is high availability deployment. That one can be achieved with at least two ECP or EDX components sharing one same external database, and at least two internal broker instances with shared file journal. Please know that regarding the file journal, the Samba and NFS version 3 protocols are not really viable for the Artemis, so we recommend using the NFS version 4, but we will go into more detail about that within the high availability webinar, which is planned in like next few weeks. The biggest advantage of the high availability deployment is when one component goes down, the system will still continue to function because there will be another component that will take over. Regarding the supported databases and other preparation before installing the ECCo, as I already mentioned, by default ECCo uses the Apache Derby, which is embedded database and fully managed by the ECP or EDX application, and does not need any additional setup. Alternatively, you can use some external database, which then must be installed and configured before the installation. The supported databases, together with ports you can see on the screen, are Oracle 19c, MS SQL Server 2019, MySQL 8, and PostgreSQL 13. If you are interested in more details about schema creation or some specific configuration that needs to be done on the database, you can refer to the ECP and EDX installation guide, chapter external databases. Another important thing that you will need to done before the installation is to obtain the installers for ECCo client components, so ECP endpoint and EDX toolbox. They can be easily downloaded from the ECCo webpage, from the link you can see on the screen. Regarding the central components, you will need to ask ENTSO-E to grant you an access to the share file. This access can be then granted by push container. The same applies for both VM installations, so the RPM and jar files, and the Docker binaries as well. And another thing that need to be done before the installation, or at least the registration, is to obtain some component code. This component code must be specific for your instance of ECP endpoint, and must be unique within each ECP network, and all synchronized ECP networks to the one you registered in. For the purposes of the component codes, the energy identification coding, or EIC, scheme is mostly used. Within the EIC, there is object type V, also called as EICV code, which is then used for identification of the locality. The ECP components may then use the EICV code in the endpoint function as the component codes. And also you can get your EICV code from your local or some center issuing office for your country. Do you have any questions regarding these common prerequisites? It's probably not a question, although these topics are still the same. So yeah. So we can maybe continue with the second and practical part, which will be the demonstration of installation upgrade covered by Michael.
So we will start, of course, by some agenda. In the first part, we will install, configure, and register ECCo client, including the endpoint and toolbox. And then we will move to upgrading from ECP 4.12 and EDX 1.13 to the latest ECP 4.15 and EDX 1.15. During the installation, we will start by installing the recommended Java version, which of course is Java 17. Then we will proceed with installation of the ECCo internal broker. We will use the encrypted passwords. Then we will install the ECP endpoint also with the encrypted passwords, register the component, and update the runtime configuration as a prerequisite for the EDX toolbox. Then we will move to the EDX toolbox itself, once again with the encrypted passwords and connection to the ECP endpoint. As the ECP endpoint and EDX toolbox will be running on the same server, we will of course need to change the ports for the EDX. Then we will do some smoke tests, like displaying the GUI and versions, and then try to send and receive messages. So let me connect to the server and let's open the ECP installation guide. Let's start on the Windows installation. We will be using the JRE 17 version of the Java, which can be downloaded from the Red Hat website. Then we will need to, after the installation of the Java, we will need to set up the JRE home system variable, not the Java home. And that should be it for the Java. So let's start by the installation. I have already prepared the installer on the desktop. So once we run it, we'll run the wizard. We can just start by accepting the license agreement. On this page, we need to associate the jar files for the Java, and then we need to set the JRE home. The installer provides option to set the Java home, which I will select, as it will be easier to set the JRE home environment variable later. Then we can press the next and install. Installer, and let's go into the environment variables for the system. Here we can see the system variable of the Java home, which was set by the installer. We will change this to the JRE home. This path points into the installation folder of the Java. So let's apply the changes. And let's open the command prompt just to verify that once we run the Java version command, we can see the Java being installed. Returning to the installation guide. Next step we should do is to configure the Java properties on the Linux system, which does not apply to us on the Windows. Then we have the firewall rules, already covered ports, which should be opened. We have the description for Linux and then for the Windows. In the Windows, you can do it using the Windows firewall application, which is described here. Then we have the default ports for the databases, the component code covered. And finally, we have the checksum verification for the ECP installers, which can optionally be done. That should be it.
Yeah, maybe there's a question from Evan. Why rename Java Home to JRE Home? Wouldn't this have side effect if any other application on the same server is on the same server that rely on Java Home? I think in theory you can have both, but commonly the ECP, it's one of the requirements for ECCo to link with this variable. So it's been like that for several releases now.
So let's go to the top. And we can proceed to the chapter internal broker installation, where the first step, of course, is the general prerequisites, which we have just done. So we can skip that part. But of course, what we should have prepared is the jar file for the installer. Regarding the installation on Windows, we have firstly describe the variables used throughout this chapter, which you can see here in this table. For example, the version is the version of the ECCo installer for the internal broker and so on. Once again, the prerequisites mentioned, the jar file, general installation prerequisites, and Microsoft Management Console, which is. And now let's start with the installation. There are two options for the installation. One is using the GUI installation. The installer package should be possible to just open by double-clicking the jar file, or it is possible to run it through the command line. So let's start by using the command line, as we will later install the Artemis broker during the upgrade, so we will show the GUI there. So maybe we can look into the guide, but installation using the command line is described. should be right about here. So we can just start the command line using the administrator system account. Then we will move to the installation, to the folder where the installer is present, and we will run the installer using this command. And then we will just follow the installation result. So let me move to the list as we have the installers present here. Try using just the java command, which just runs the installer GUI. On the first page, we can see where the ECCo Artemis will be actually installed. We will be using the default installation folder, which is the C program files followed by the ECCo component name. Of course, information that the ECCo Artemis folder will be created. Then we can register the application as a Windows service. If we would not do this, the service or the application would have to be run using the Tomcat startup and shutdown scripts provided in the installation. I will install it as the service. Then we have the option to set the service to start on server startup. I will not select this, however, you of course can. Then we just proceed. Next. And then we have the password settings, which we can use either the default passwords, then the passwords will be stored in plain text, or we can select the custom passwords, which lets us to store the password hashed for the user passwords, and for the keys for password, we can select the encrypted form. So now we have the user account password, so we just fill in the our very secret values. And we just select once again to next. Then we have an option to create an automatic installation script, which can be used if the installation would be the same on multiple servers. Then we can just create this script to make the installation faster and easier. So let's just press the done button, returning to the installation guide. We have just covered the GUI installation chapter, which is further described in the documentation with all the options described in more detail.
Yeah, maybe before we move to the next step, there's another question. If the open logic, OpenJDK can be used, it might be possible that some other distributions will be fully compatible with the ECCo, but we are not sure. Still, the Red Hat OpenJDK is recommended, as we are sure that it covers all the dependencies necessary for the installation of ECCo. So regarding the OpenLogic, we are not sure.
So to continue, next chapter after installing the ECCo Artemis broker is to start it and perform smoke test. However, before we do that, we will proceed with configuration of the Artemis broker. As we have installed the ECCo Artemis here. So once we open the installation folder, we can see multiple folders present. The obvious one is the uninstaller, which obviously contains the uninstaller jar. But then we have two folders, one of them being the Artemis and one of them being program. if we would look into the Artemis folder, this folder contains core files for the Artemis installation. It contains all of the libraries used for the operations for the Artemis. You will most likely not need to change anything in this folder. From this folder there is a broker folder created. This folder contains the instance of the Artemis broker, which is basically, as we can see, the size of it is just 4 megabytes, and for the Artemis it's 65. The broker folder is a lightweight instance of the broker which is actually run. It is possible to create more instances from this main Artemis folder. However, we are not using this feature in the ECCo. Then, if we go into the broker folder, we can see the most important folders. First, we have the binary folder, which contains the Artemis command and Artemis service executable file, which are used to run the Artemis. Of course, the Artemis service is used for the Windows service being run, and the Artemis is a tool that can be used to run the Artemis not as a service, or it offers some useful options, like using this command can be used to detect, to connect to the web console using the command line, or to connect some configuration parameter, which we'll show in a moment. What is good to mention that all of this was covered more in detail in the new features webinar that was already covered. Then we have the ETC folder, which contains actually the configuration files for the Artemis instance. First, we can see the Artemis roles, users, and login config. These files are used for the security purposes, like the roles and users used to access this Artemis program. By default, the Artemis comes with the user endpoint with its password being encrypted, or rather hashed. It is not actually encrypted, this is just the hash. And of course, the default credentials are endpoint and password. In the Artemis roles properties file, we can find this user being assigned to the AMQ role, which is used across the configuration. And last, regarding the credentials, we have the login config, which contains the properties login module being required to access the internal broker. What we will do now is that we will create a new user. This user will be used by the toolbox installation. So to create it, we will create a toolbox user, and following the equals mark, we put the actual password. The password can be either plain text or hashed, and in case it is hashed, it must be surrounded by these, by the ENC and the brackets. After that, we have to go into the Artemis roles properties, where we have to assign the toolbox also to the AMQ role. However, as promised, we will use the encrypted passwords. So I will move to the installation folder of the ECCo Artemis into the binary folder. I'm missing the program/bin. Here we can see the Artemis command, and we can use it to create the hashed password. The syntax of the command is the command itself, then the option to mask, hash this input string. So when hitting enter, we can see the result being the hashed password. Now I can copy it and put it into the this file. And like this, we have created the user for the toolbox, which we will need later on. This is of course covered in the administration guide of the ECP. So we can take a look at that. Chapter 6.5, user management, where we have the Artemis users described the syntax of the users being the username followed by the password. And then we have the command how to hash the password for both Linux and Windows. Now let's continue with the configuration of the broker. Next two files are the bootstrap XML and the Eurokia access XML. These configuration files are mainly used to configure the web console. So let's open them. The bootstrap XML is used to configure the web console. So we have the binding element under the web, and this element tells us where the internal broker web console is running. We can see that by default it is using the HTTP protocol. It is listening on the localhost network interface on the port 8161. As we are using Windows server, we will be able to access it from the localhost easily. However, if you would want to access the web console from different server, then we will need to change this value. We can either put 4 zeros, which basically tells us that the web console is running on all of the interfaces, or we can put the IP address of the server, which will limit it just to the IP address. Another little interesting part of this configuration is the app console element, which tells us that the console is running on this URL/console. And next, we have the URL for the metrics, which is used for the Prometheus metrics. We will see another configuration for the Prometheus metrics in another file. But this tells us that it is running on the metrics URL. If wanted, you can change this. Next, we have the Eurokia access XML. This file is used for as a protection against the source origin website requests. By default, again, we have the localhost here. If we would want to access the web console from a different host, we can put either just the asterisk, which tells us that the web console is accessible from anywhere, or we can put the IP address of the server in this field. So let me copy it. The IP address followed by the asterisk, which, by the way, is where the server is listening. Just to make it a little easier, I will leave just the asterisk. Next, we have the broker XML file. This is the most important file regarding the configuration. So let me quickly cover the contents. Once we open it, the first thing we can see is the name element. This is the name of the internal broker that will be displayed in the web console. This name is also used in the Artemis command for accessing the operations, the JMX operations using the command line. Next, we have the persistence enabled, which basically tells us that the messages are being stored on the hard disk and not just in the memory. This is, of course, the same as it was on the ActiveMQ. However, next part we have the directory settings. The data folder and for other folders are used to store the journal of the internal program. This is the place where the persistent messages will be stored. One thing that we can notice is the HA prefix in this command, which basically tells us that we should pay a little more attention to this. Well, it is important and used for the high availability setup. I will not cover these properties in detail as they will be covered in the HA webinar on October the 24th. Scrolling down, we can find the journal buffer timeout. As we have already mentioned, the messages are stored in the file journal. Due to performance reasons, the Artemis broker keeps the messages in the memory, and then any updates to the message is being flashed in an interval. This interval is defined by this property. So this is because it is not wanted to access the persistent storage after every update on every message. So due to performance reasons, it is done periodically. By default, the ECCo Artemis comes with a value of 20,000 predefined. However, this might not be the right value for you. And to configure this property, we can once again use the Artemis command with the option perf journal. I think delicious. Not to be feared. This is of course covered in the installation guide. Or maybe the administration guide. I remember now that this is just the paragraph now. So now what we can see is that the URI for the bootstrap cannot be found. This is actually a known issue with the default installation pointing to a folder with the space in it. As we can see, we have the space in the program files. This should be fixed in the 4.15 and should be not an issue for you.
Yeah, we can maybe skip this for now. It was all regarding the previous webinar when we have shown on the Linux how the command works and what will be the output of that. So yeah. Also, as Mike mentioned, this is already known. We are currently in SATs for this version, so this will be fixed in the final release.
So maybe just to mention the output of this command, the output would be this property with the correct value. I would recommend to run this command multiple times, as the result highly depends on the load on the server. To continue, next really important property is the max disk usage. This basically limits the usage of the of the ECCo Artemis internal broker on the server. It is not possible to define some limit, let's say 100 gigabytes. We must use this property, which tells us that the internal broker can use up to 90% of the persistent storage on the server. So let's say we would have a server with 500 gigabytes allocated to it. We would let's say want to limit the internal broker to just 100 gigabytes. We can put 20 here to indicate that we want to use just 20% of the server. I don't leave this with the default 90. Next, we have the acceptor settings. This is the acceptor of the Artemis broker, which tells us where the broker is listening. We can see that it is listening on all of the network interfaces of the server. This once again can be set to just localhost or the IP address of the server. Then we have the port 5672, same as on the ActiveMQ, embedded broker, and some other options. So first one is the SSL enabled, which tells us that the IMQPS will be used and not just the IMQP. Following, we have the key store path, which points to the key store in the etc folder, which we can take a look here. This key store is provided by ECCo installation, and it contains a default certificate valid for 10 years. One thing to notice is that we have, instead of a space, we have the %20. This is URI, which means that spaces are not allowed and have to be encrypted. %20 is the space. Then we of course have the password. We can see that it is being encrypted. By default, it is the password, like password, followed by the trustor path and password, pointing to the same key store. And on the end, we can see the IMQP protocol being enabled on this acceptor with enabled protocols TLS version 1.3 and default ciphers. Next, once again, we can notice commands referring to the high availability setup, which I will skip in this webinar. Next, we have the security settings and address settings. These settings are, the security settings are used to indicate which roles can perform what operations. By default, the ECCo Artemis comes just with the AMQ role with the administrator privileges, which can perform anything. Then we have the address settings. Important element here is the actual address setting. We can see the match is the hashtag. This tells us that all of these settings will be applied to all of the queues. So for all of the queues, there will be these two queues defined, the deadletter queue and the expiry queue. Difference with the ActiveMQ is that we are using the expiry queue for the messages that are expired, that they have the DTL expired, and the DL queue is used in case the message encounters some exception during its process. The exception can be either on the Artemis server side or the ECCo client side. Then we have the max size messages, which tells us we can store an unlimited amount of messages in the queue. And then we have a paging configuration, which we will get back to in a moment. On the end of the configuration file, we can see addresses which are predefined. The DR queue and expire queues, these two queues will be created on broker startup by default. Next, we have plugins configuration. First one, we have the Prometheus metrics plugin, which enables Prometheus metrics to be accessible through the web console. Next, we have the ECCo audit logger plugin. This plugin is used for the audit message logs regarding the internal broker. These were previously present in the ECP or EDX components logs. However, as the internal broker is now externalized, these logs are logged in its logs. There are two configuration properties. First one being the ECP component code, which should be the component code of the ECCo instance using this Artemis broker. And then we have component type, which of course is preferred as it is the internal broker. It is good to mention that these properties are just used for the logging purposes, and you can put any value here. These will be reflected in the audit logs. So if you would put anything different here, so let's say ECCo shared Artemis internal broker, you can, as already mentioned on the start of the webinar, the internal broker can be used by multiple ECCo components at the same time. If it would be this case, then you can put all of the component codes in this value, or you can just put the shared internal broker. This is up to you, and you can find what suits the most to you. I will use for the bool, as this internal broker will be used by the component code bool. Few properties that I have intentionally skipped. In the address settings, we have the max size bytes. This property tells us how many bytes can be used by this queue. This is talking about the memory. By default, we have enabled 100 megabytes for each queue. This is not shared across all of the queues. This is per the queue. Once this limit is reached, the queue will go into the paging mode, which means that all of the extra messages coming into this queue will be stored in the persistent file journal. Related property, a little higher, we have the global max size. This property tells us the maximum memory that can be used by all of the queues combined. Once this limit is reached, all of the queues will go into the paging mode. Even if they have, let's say, just 1 megabyte of messages in the memory, they will go into the paging mode. And last property regarding the memory usage of the internal broker is configured in the in the Artemis profile command file and the Java args property. Here we can see the XMX Java property that is used to limit the maximum usage of the internal broker itself. By default, this is 4 gigabytes. You can notice that here we have just the 800 megabytes. It is recommended that the XMX value is higher than the global max size. Due to performance reasons, it is recommended that the value should be about 2 or 4 times this value. So this would be all for this configuration file. And well, all of the files. Oh, what I forgot is the LDAP configuration. Of course, the internal broker comes with an option to configure LDAP or Active Directory authentication. To configure this, you need to copy these files into the main etc folder. Just to have a look. We can see the login config now having the properties login module and LDAP's login module. The LDAP's login module is used for the access to the web console. We can see some different values predefined. However, you need to, of course, configure this according to your environment. But by default, we can see the LDAPs being enabled, running on the localhost port 636, the transmitter and keystone location, and so on. This is, of course, described in the ECP administration guide. Going back to the broker folder, then we have 4 remaining folders. The library, which contains the jar files for the plugins. Here we can see the Prometheus metrics plugin and 2 jar files for the audit log. And once we will start this broker, we will see 1 extra folder, which is the data folder storing the file journal. And of course, we have the log file containing the logs. Of course, this will be created after we run the Artemis. So maybe let's see if anyone has any questions regarding the configuration.
No, I think no questions.
No questions,
yeah.
Just to mention this once again, all of this, which I have just covered, is also covered in the previous webinar in a little more detail. So let's go back to the installation guide. And let's continue with starting and stopping the internal broker. We have installed the internal broker as a service, which means we can use the Windows services utility to run it. Otherwise, we would need to use the Artemis command to run and stop the application. This is the command we have used for hashing the password and so on. Another option, if the Artemis is installed as a service, you can also use the sc start and stop commands if not wanted to use the GUI of the Windows. So let's start the internal broker. I can see it named as ECCo Artemis, so let's start it. And in the broker file folder, we can see the data folder being created, which contains the 4 file journal files. And let's open the log file. So what we have here is the audit log and the Artemis log. The audit log is empty for now, as there were no audits, of course. And then we have the Artemis log, which is the main logging file. Here we can see that the IMQP protocol is running on all of the web interfaces of the server on the port 567, and also we can see the web console running on the 8161. You can see the console URLs here. And then in the web browser, by default, as we could see, we can use the endpoint password credentials. Once we open the console, we can see the ECCo Artemis internal browser. Just for the reference, we can open the configuration once again. Scroll up, and we can see the name being used. This is the same value. Next, we have the acceptors and addresses. Here we can see by default created the DR queue and expire queue, which we have defined in the end of the file, right here. And the acceptors, we can see the IMQPS internal acceptor being enabled. This refers to the acceptor defined right here. Next, we have some tabs here. These will be now empty, as we have not connected the endpoint and toolbox to it. So I will cover these after the installation of the endpoint and toolbox. So just for now, we can see that the Artemis broker is successfully running and should be operational. So let's get back to the installation guide. Let's scroll up. Let's take a look at the chapter 8, the endpoint installation. Once again, we have the common prerequisites, which consist of preparing the jar or RPM file, registration key store provided by the component directory administrator, and note we should perform the general installation prerequisites first. However, we have done them already. So let's move to the installation on Windows. Once again, variables used throughout this chapter. Prerequisites, basically the same as on the Artemis internal broker, and actual installation. Once again, we have the GUI installer described here. So just clean the equipment. I will once again move to the desktop, where we have the ECP endpoint installer located. So let's start the web console, I mean the command line. Let's move to the desktop. And once again, let's start the installer. So once again, first page we have is to define the installation path of the ECP endpoint. Default the program files. We can also choose the installation type, which for us is obviously the standalone application we are upgrading or installing to an existing application server. So let's just proceed. I will register the application as a Windows service. I will not let it start automatically on server startup. However, it might be feasible for you. Once again, the password settings, I will select the custom passwords, which let me to use the hash or encrypted passwords for the user accounts, and for the technical accounts we have plain or encrypted. I will select the hashed password here and encrypt it for the technical. For the encryption, we should define some encryption key with the encryption algorithm. I will leave this algorithm as by default. Next, we have the password for administrator account. Then we have the technical accounts. Here we can find the password for key stores, for internal broker, and the CCRF secret. So just fill these values. The authentication key store is the file stored on the file system. Then we have the internal broker. We have to make sure to use the same password that is defined in the configuration of the internal broker. Then we have the key stores in the database, which are the key stores stored in the database, not the file system. And then we have the CSRF secret. This was added in the version 4.14, and it is new mandatory property. This property is used in the GUI of the ECP endpoint and toolbox to generate the cross-site request for Jerry token. So let's just continue. Once again, option to create the automatic installation script. Let's get back to the installation guide. We can once again see all of this described, maybe in a little more detail. Scrolling down. We get to the verification and starting and stopping the ECP endpoint. So maybe to cover the files in the configuration folder, the difference between the IMQP internal broker, the ActiveMQ Classic and ActiveMQ Artemis, we can see that we are missing the users and roles properties that were used for the ActiveMQ. We will see this better in the upgrade guide during the upgrade. Looking into the ECP properties, there is the little change. We can see the HA configuration, part of the configuration, missing the properties for the external broker, external broker, and then we have the internal broker configuration. We can see that most of the properties did not change. However, their purpose did a little bit. In this property, we are defining the user that will be connecting to the internal broker. We have to make sure that the endpoint with the default password is also present in the configuration of the Artemis internal broker. Then we have the configuration of the key store, specifically the out key store used to connect to the internal broker. During the installation, there should be no issue. However, we may have to make sure that both the out key store in the ECP endpoint installation and then the key store JKS located in the configuration folder of the Artemis both have the same certificate authority. By default, this certificate authority is supplied with the ECCo installation. Scrolling down, we can see the ECPC SRF secret defined in the document. This property must be defined with the value. Also, what we can notice is that all of the passwords are encrypted. This will also apply to the users defined in the ECP users properties. However, we have chosen the hashed passwords, so we can see the hashed being defined here. So let's proceed by refreshing the services utility, and we can see the ECP endpoint right here. We can start it just by pressing the start. The logs are located in the tomcat/logs. You can see the Catalina and endpoint logs here. Until the endpoint is started, we can take a look into the documentation. We have started the service using the service utility. Other options we have is using the command line, either by using the sc start, or if not installed as a service, we need to use the Tomcat startup scripts located in the binary folder. Let me scroll up and we will proceed with the registration of the ECP endpoint. This is covered in the chapter 9, the ECP endpoint registration and smoke test. So let's start with prerequisites. We should have the internal broker running, which we have. We should have the endpoint started, which we hopefully have as well. And we need to have the component directory, URL, the registration key store, and the component code that will be assigned to us. The endpoint is of course running on the port 8443 and using the default admin password credentials we can log in. In the documentation, we can see the registration process covered with screenshots and description. So let's start with the registration. We need to use the registration key store. I have already prepared it on the desktop. This is registration key store provided from the component directory. Then we need the URL of the component directory with its component code. Once we fill in the values, we check the connectivity, and in case we have some mistake here, it will inform us in this message. We do not have such issue. We can just continue. Here we will fill in the component code, which for us will be the board, project name, we will fill the webinar, and for the environment, we can put the name of the server.
Maybe just a small note that project name and environment name are optional fields. You don't need to fill them if you don't want to. However, it is a great label to recognize the endpoint like directly straight away, because those names that you define will be then displayed on the top of the page right next to the endpoint word. So
Right here.
yeah.
We will see that in a moment. In the meantime, I have filled in the contact information. I also need to accept the GDPR screen, and we can submit the request. After submitting the request, we will be redirected to the endpoint dashboard. Which will inform us that the endpoint is not yet registered, that the registration was not yet approved, and that we have no message paths defined. So let's open the component directory and let's approve the request. Now that we have accepted the request, the endpoint registration status checker, which is running every minute, needs to fetch this information from the component directory. As we can see, this was already done, and the component is registered. After refreshing the page, we can see that we are missing the message paths. After logging into the administration account, we can go to the settings page, scroll down to the paths, and we can define indirect message path using the Gorilla broker. We can see the asterisk, which tells us that any message type can be used for this internal broker, ECB broker. Validity set. We'll leave that default. So let's save this message path. When going to the dashboard, we can see that there are no invalid message paths and the endpoint should be ready. With the installation guide, we should be ready to go. We perform the initial smoke tests. We can check the connectivity to the component directory. We can see that we are successfully connected, and then we have the message connectivity, which I can, let's say, use testing message type and check the connectivity to other endpoints in the network. This will probably not work yet, as the ECB broker did not synchronize with the component directory yet. So it doesn't know about this endpoint. The synchronization by default is every 5 minutes, but this highly depends on the environment you are connected to. Let's try it once more. Okay.
Maybe just give it some more time to synchronize and continue with the rest.
Yeah, we can see that the message passed, but if we do it once more, we can see it being done a little faster. Looking into dashboard, we can go into this tile where we can see the Gorilla broker be connected. Next, what we will do is a prerequisite step for the installation of the ECTX toolbox. In the EDX installation guide, I will go to the chapter 614, which where we have defined what we need to configure on the ECP endpoint for the EDX toolbox to be functional. Of course, we have the internal broker. We will go through that during the toolbox installation. However, regarding the ECP endpoint, we need the IMQP API enabled and also have the IMQP API set handler enabled as well for desired message types. We will configure this now in the runtime configuration, and we will use the asterisk to indicate all of the message types to be forwarded from the endpoint to the toolbox. So once again, logged into the administration account, I can go into runtime configuration. I can either export the configuration and do it manually there, or I can use the GUI editation of the runtime configuration. As mentioned in the guide, I will need to enable IMQP enabled and set the set handlers. So first, let's enable the IMQP API. And then let's scroll down to the set handlers right here. For the bean name, I will use the default IMQP API set handler. And for the type name, which are message types, I will use just the asterisk. After this, I can just save the configuration and the endpoint will reload its context. Now, if we go back into the Artemis web console, we can see little more than previously. First, let's go to the tabs. The default tab is the status, then where we can see the cluster info, for example, that we only have single deployment and not the HA. Also the broker info, like the version of the Artemis broker and its uptime. Then we have the connections tab, which can be, let's say, used for the debugging. We can see that there is a user endpoint connected from this IP address. We can see that this is the ECP endpoint. Its sessions created, which basically are the consumers and producers. In little more detail here. And then we have the address and queues. In the queues, we can see all of the queues defined. For the internal broker, what we can do here is that for any of the queues, let's say we will use the let's say the endpoint outbox. We can use it, this number here, the message count, to access the queue. This will let us to browse the queue. If there are any messages, we will see them here. Regarding this queue, what we can now here, what we can do now is we can either manually send a message, which probably not be used as often, but there are also options to, let's say, delete the queue, which contains the option to purge the queue in case there are some messages that we want to delete. This will mainly apply to the DL queue and the expire queue, or we can delete the queue entirely. Also, what we can do is we can go to the operations tab and we can see the JMX operations defined here. Of course, we can once again browse the queue, or we can even pause the queue. After that, we can resume it. These operations should be similar to operations present on the ActiveMQ Classic. So now that we have finished the ECP endpoint installation, let's now proceed with the installation of the EDX toolbox. So once again, we open command with prompt on the desktop. I have the installer right here. And let's start the toolbox install. Of course, let's open the installation guide as well. Firstly, let's go through the general installation prerequisites. Once again, it is the Java. It is the same Java used by the ECP endpoint and Artemis broker, for which we have already done this, so we can skip this. Once again, the firewall for the ports. Here we can see the toolbox running on the 8443. However, as we are using same server for the endpoint and toolbox, we will be using the port 9443. Here we have description how to enable the ports on Linux, of course on the Windows, same as on the endpoint. Then we have the ports for the databases, obtaining the component code, and last, the installer checksum verification. So let's get back to the toolbox installation chapter and start. We can see the EDX network overview, how usually the network looks like. Basically, we have a network consisting of one service catalog and lot of toolboxes, all of them being connected to the ECP endpoints, which are connected to the intermediary ECP broker, here defined as just the ECP network. Next, we have the network communication protocols. We can see that the toolbox is communication with the internal broker using the IMQPS. Same applies to the service catalog. Then we have the protocols on the ECP network, of course, once again, the IMQPS. Then we have the HTTPS protocol between EDX toolboxes. This will be used if the external pull interface or just the pull messaging could be used. Next, we have the deployment modes. Once again, we can use either the embedded Derby database or the external database. The external pull interface, if desirable. Then the EDX application has to be sharing system file folders with the pull interface. However, the pull interface is not required. It can be embedded in the EDX toolbox as well. Then we have the high availability setup described here with toolbox applications with the database and FS server, which would contain mainly the DMS folders, but in case FSSF would be used, this folder will be shared here as well. And finally, we have the general prerequisites before installing the EDX toolbox. First prerequisite is to have the internal broker configured with the credentials. We have done this already in the first part during the installation of the internal broker. We have added the toolbox user with the default password. We can notice that we have the internal broker and the ECP broker. The ECP broker is the internal broker of the ECP endpoint. as we are sharing the internal broker between the two components, these properties will be most likely configured with the same values. Then we have the ECP endpoint chapter, which we have done just now. We have enabled the IMQP API. Then we have service catalog configuration mentioned here, that we need the component code of it. And of course, we will need to add our toolbox to the service catalog. Allowed buttons for the ECP endpoint code, however, this will most likely be covered already during the installation of the endpoint. And let's start with the actual installation. Once again, prerequisites is the enabled internal broker with IMQPS. We have done that. ECP endpoint up and running, already done. Toolbox installer, we have just started it. And prepares parameters, also the Java. So once again, in the documentation, we have covered the how to run the installer. This thing is on the endpoint, so I will go through this rather quickly. Once again, screenshots from the installer. Start and stop the application. So let's proceed with the installation. We are doing a new installation of the EX toolbox with this installation path. The toolbox folder will be created, of course, and then we have two options. Once again, to register the application as a Windows service, we will leave this enabled, and to change the default ports if the endpoint is installed on the same server. This is our case, so I will check this mark, and this will result in the GUI ports changing from the 8443 to the 9443. Then once again, automated start during the server startup. I will leave this disabled. And let's proceed with the installation. Once again, we will choose the custom passwords, which will allow us to use the hashed passwords for the users and encrypted passwords for the technical accounts and properties. Once again, encryption key with the default algorithm, same as on the endpoint. Administration account credentials, and once again, password for the key stores for the internal broker. This is the toolbox password. User credentials we have filled in previously. Database connection and the CSRF secret. Let's proceed. Once again, option for the automatic installation script. Before starting the EDX toolbox, we first need to configure it. Once again, in the program files, EDX properties. First thing to notice is that we are using the encrypted passwords. You can see it here. And on the end of the configuration, we can see the EDX CSRF secret. So first we need the toolbox code, which is the same code as used on the endpoint. Then we have the component code of the service catalog, which for me, this would be the elephant. Scrolling down, we have the internal broker and TCP broker properties. Once again, these properties did not change since the 4.12 and 1.14. However, their purpose is a little bit different. Here we have to define the user that will be used to connect to the Artemis broker. We have to make sure these credentials are defined in the Artemis configuration. Once again, the key stores by default, the EDX toolbox comes with a key store containing the correct certificate authority, valid for the 10 years once again. And then we have the host and port properties. The host refers where the internal broker is running. As it is running on this server, I can leave the localhost value here with the 57672 port. Then we have the key prefixes properties covered in the previous webinar. And I think this should be everything. We can take a look in the EDX users and we can see the admin account and admin account having the password hashed and not encrypted with the role of service manager. Looking in the installation guide, once again, we can find information how to start the service. If installed as a service, the SC command with the option start or stop. If not installed as a service, we have to use the Tomcat binary startup and shutdown scripts. If installed as a service, we can once again use the services utility. So let's start the EDX toolbox. After refreshing services, I can see it and I can start it. What we can take a look at, if we will look into the properties. The ports being defined.
That's where the Tomcat file and language binaries, but I think just the fact that you started it and it's running means that the ports are not the same, so we can just go to GUI there.
Yeah, we can of course look into the log as well.
Logs.
In case there would be collision with the ports, we would have the warning or rather error logs being displayed. So to access the GUI, let's see if we have already started. It seems so. And we can see that there is some issue. We can see that we have issues connecting to the internal broker. This is most likely due to a misconfiguration. So let me go into the EDX properties and verify the credentials used for the internal broker. I will just for now, I will copy this and comment on the encrypted form, and just to be sure, I will put just the password. If I did not make a mistake within the installer. Here. Let's put the password here. So the user toolbox with the password. And to verify this, I will probably also go into the Artemis broker etc folder, the users, file. I will make a copy of this one, and just to be sure that we are using the password, I will put it in the plain. Of course, we can copy this hashed value, which also is the password. So now let's quickly restart the Artemis internal broker and the toolbox. Just to try that, we can use the toolbox password just to see if we can log in. And we can see the queues. We are logged in, so on the Artemis we should be using the correct password. And the toolbox logs.
Yeah, like maybe this is a great example of some like common mistakes that can happen within the process, or like one small typo can create this issue. But yeah, it's obviously fixable. If you would wanna change the already encrypted password, I think you would need to encrypt manually using the Yolkia, I think.
The asset.
Yasip, oh sorry, yeah, Yasip.
This is described in the
Yeah,
documentation, of course. Now we have the toolbox up and running. And going into the settings tab, we can see that the network configuration was already received.
I think it's important to know that normally there won't be any network configuration. However, this one was already received because Michael did it during the preparation for this webinar. So the toolbox was already manually added to the network configuration of the EDX service catalog. So yeah, just explain that it might not look like this when you install it.
On the endpoint, we can also see the ADX internal configuration messages being sent to the elephant, which is the service catalog. But for smoke test, we can send the message to the, let's say, to the elephant. Let's say some testing type, and send the test message. Going to the elephant endpoint, to the inbox. I can see the message being received here. I can download it and see the contents being done. The testing message, successfully receiving the message. So that's for the installation of the ECCo client.
Yeah, and if you're gonna go back to the presentation, maybe let's just quickly go through what all we have done. So we installed the Java 17. They continued the internal broker successfully as well with ECP endpoint, EDX toolbox also works. Maybe just show the version of the GUI just real quick. And as we are running short on time, we will maybe just mention some important stuff related to the upgrade itself. Because the upgrade is basically still the same as on all the previous versions. So we will just open the installer, choose the upgrade option, and hit a few next buttons, and that's all. The only change there is that you need to install additionally the internal broker, which was already covered by Michael within the installation itself. So technically, we've already seen that. There's one thing that's necessary to know and keep in mind. Before the upgrade, you need to let the ECP endpoint process all the messages from the queues, because those data from the ActiveMQ tables from the database are not migratable like easily to the file journal. So during the upgrade, there is mostly guaranteed the data loss when you don't have like processed all the messages. So we go back to the presentation. You check the slide of the upgrade. Yeah, so as I mentioned, the internal broker, it's necessary to make sure that there is no message within the queue, and then upgrade of ECP and EDX is still the same. Within this release, we got like 6.80 upgrade of Java 17. However, it's just from some build or minor version to the latest one. There is no mandatory change of Java, like jumping from, let's say, Java 17 to, I don't know, like 20 is the new most one.
17, 0.
No, like I mean the major version. Yeah, but there's no like migration of Java, so this upgrade is still kind of simple. Are there any questions regarding the installation, or do you have any like additional questions or requests for some additional information regarding the upgrade? If not, you can.
Yeah. So thanks.
Well, I think we can just wrap it up, and yeah, thank you for the attention.
Yep. Thank you everyone. And sorry, Vince, we timed it, but looked like the changes took more time than what we thought about. So we will look into it. But if you have any questions related to the upgrade specifically, you can reach to us. But as Daniel mentioned, most of the things is similar, and you can find other upgrade related webinar videos from the previous recording. It's available on our YouTube channel. We'll try to plan it in more detail or more accurately to next time. But yeah, since we don't want to extend, as there are other meetings planned and it's already been 2 hours, so we don't want to bore you with more detail into it. So yeah, so if you have any questions related to the upgrade on the Windows, then yeah, do message us or let us know, and we will be happy to help you. And if there is no other questions or comment, then thank you very much for attending today's webinar. We have 2 more planned, one for Linux machine, which is on 10th, and then 24th, we have high availability setup webinar. So don't forget to join them. And if you don't have the invite, just let me know. I will forward it to you. Yeah. So I think we can close. Thank you, everyone. Have a nice day and the weekend. And
Thank you.
thank you very much.
Yeah.
Bye-bye.
See you next one. Bye.
Thank you. Bye.